Hello and welcome to another one of D's ADD videos. Today we're going to discuss the concept of acids and bases. Throughout history there have been different definitions of acids and bases, and the very first attempt to define these species was done by Arrhenius, where he said that an acid was anything that reacted with water and gave the hydronium ion or a proton. Either or can be used here interchangeably. And then he said a base was anything that reacted with water that created the hydroxyl ion. So his definition was based with the reactions with water. But a couple of guys came along and said, well, not all acid-base reactions occur with water. Sometimes water is completely absent from the reaction that's acidic and basic in nature. And they decided to look at protons. What's happening to the proton? If it's being donated, it's usually an acid. And if it's being accepted, it's usually a base. Not usually, it is a base, sorry. So conjugate acids and bases, as a result, differ in just one hydrogen in these reactions. Okay, so for example, this is acetic acid. This is the acetate ion. The only difference is one proton. Therefore, these are conjugate acid-base pairs. So acid strength is inversely related to the conjugate base strength. So the weaker the conjugate base, the stronger the acid, and vice versa. So it's an inverse relationship. Okay. Alrighty. And the equilibrium of the reaction favors the weaker acid-base pair. And we're going to go through different examples of all these concepts. So just for now, try to get a rough idea of what's going on, so when you do watch example videos, you don't panic. So what makes an acid strong? How can we compare acid strength? Well, one thing is, the more stable the ion that results after the proton donates, or after the acid donates its proton, is the stability of the ion that results. The more stable the ion, the stronger the acid is. That's why resonance aids a great deal in increasing acidity. What resonance does is it basically shares the burden of the charge among multiple atoms, or elements. So for instance, if you were to have something like this, this one has a -1 charge if you were to do the formal charges and the correct Lewis structure. And this one's neutral. However, if I switch them, well, this is on the resonance video as well. Now this one has the -1 charge. And what happens is you get a resonance hybrid, which basically has a -1/2 charge on both of those, so thereby increasing stability and making it a better acid. Size also matters in this case, so the bigger the anion, the more stable, therefore the better acid. Okay? Well, some time passes, and some people say that not all reactions involve proton donation. So let's look at it from a standpoint of electrons. If we look at it from a standpoint of electrons, we can say, okay, well, which one is donating the electrons to form the bond, and which one's accepting the electrons? If it's accepting the electrons, it's an acid, and it's usually electron poor, that's why it's accepting them. And we call such species that are electron poor electrophiles. This term will be used a lot later on in your study of organic chemistry if you get that far when we deal with nucleophilic and electrophilic reactions. So a Lewis base, in contrast, is going to be electron rich, the donor, because it has too many electrons, and we refer to that as a nucleophile. Okay. So those are the basic concepts behind acids and bases. So make sure you are able to distinguish the definitions. Know that each definition can be applied to the one previous to it. So for instance, this does donate a proton to get that. All right. This accepts a proton to get this. So it fits a classical Bronsted-Lowry definition. Same thing with Lewis acids and bases. We're going to have the accepting of electrons to form the bond here, as well as the donation of the bonds up there. Okay, so make sure you know the definitions, and make sure you check out the example videos for acid strength, and practice as always. I hope I've eliminated any doubts you might have over acids and bases. Thank you, and have a nice day.